So here's where we get to see where this long division or synthetic division is useful when it comes to solving polynomials and factoring. Um, in this section, we'll be given something that is a factor or a zero. So in this first example, where we have f of x equals 2x cubed minus 11x squared plus 3x plus 36, we're told that x minus 3 is a factor. Now that means that x minus 3 should divide evenly into something, right? Think of the number 24. If I tell you that 12 is a factor, that means that 12 times something, some whole number, should give us 24, right? And so if we were to do 24 divided by 12, we should get what's left, and maybe we can deal with the factors of that piece that's left. Okay, so given a factor, we're going to use either long division or synthetic division. It's up to you. We're going to use that to divide that factor out, and then we'll maybe be left with something else that we can factor. So I'm going to use synthetic division. I think that's the easier process, especially when we get to the next section where we have to do some guessing and checking. But here they tell us that this is a factor, so there's no guessing, there's no guesswork involved. So again, if x minus 3 is a factor, the 0 that goes with that is 3. So we know that 3 is a 0. So if we were to plug in 3 and evaluate f of 3, we would get 0. Okay, so we're going to use synthetic division to divide that out. So we're going to do synthetic division with our 3. So we have the 3 there, and then 2x cubed minus 11x squared plus 3x. I guess we don't need the plus, but plus 3x plus 36. So synthetic division, again, we bring down that 2, or you can think of it as adding. 2 plus nothing is 2. 3 times 2 is 6. Negative 11 plus 6 gets us a negative 5. 3 times negative 5 is negative 15. 3 plus a negative 15 is negative 12. And 3 times negative 12 is a negative 36. And when we add that down, we get 0. So two things that tells us is, one, the remainder is 0. So x minus 3 divides evenly into that polynomial. Also, if we were to plug in 3, this is telling us that we would get out a 0. So that confirms that x minus 3 is a factor and x equals 3 is a 0. So what we can do now is we can say that if we divide out x minus 3, we're left with the polynomial that we get from that 2, negative 5, and 12. So we had started with 2x cubed. We've taken out an x. So now we have 2x squared minus 5x minus 12. And in this case, we don't have a remainder because that remainder was 0. So now we've factored something out, and now maybe the rest of this factors as a quadratic or by grouping or one of those other strategies we had looked at before. So does 2x squared minus 5x minus 12 factor? If we're multiplying to a 2x squared, one of these has to be 2x. One of them needs to be x. We need to multiply to a negative 12, so they have to be opposite signs, but which one goes with which? So if you pause and play with that for a little bit and get that factored, you should end up with 2x plus 3, x minus 4 is how that factors. Okay, so we've got that factored completely now by using that factor that we were given early on. And just for the sake of, again, connecting all the different pieces, if we were trying to find zeros, right, then x equals 3 is one of our zeros, x equals 4 is one of our zeros, and here in the middle you would set 2x plus 3 equal to 0 and solve for x, and you would get x equals negative 3/2 is a 0. Okay? So our second example here, instead of being given a factor, we're given a 0. So we're going to use 5 in the synthetic division, but what is it that we're factoring out or dividing out? Well, the factor that goes with x equals 5 is x minus 5, right? So once we get it divided out, that's the factor that has come out. So we set up our synthetic division. So 5, 3x cubed minus 2x squared minus 61x minus 20. And again, with these, you could do long division if you want. You could do that polynomial divided by x minus 5 and use long division. But I would really recommend giving the synthetic division a shot, especially for next section. It's going to speed up the process a lot to use synthetic division. So doing our synthetic division, we bring down the 3. 5 times 3 is 15. Negative 2 plus 15 is 13. 5 times 13 is 65. Plus the negative 61, that gets us back down to a 4. 5 times 4 is 20. Negative 20 plus 20 is 0. So again, this confirms that if we plug in a 5, we get 0. And so that factor divides out evenly. So f of x equals x minus 5 is the factor that we have divided out. And everything goes down 1 power. So 3x squared plus 13x plus 4. So one last step of factoring. We know this is going to be 3x plus an x plus. If we want to get all the way up to 13, well, 3x times the 4 would get us close to there. So 1 and 4 would give us that plus 13x. So that's how that factors. And again, maybe one last thing to consider, if we were looking for all of the zeros, right, what would make each of those zeros? Then x equals 5 is one of those zeros. X equals negative 4 is one of those zeros. And if we set that equal to 0, subtract 1, divide by 3, negative 1/3 would be our final 0 there.